Okay, so we are on the shot 0040. This one is very key because it was the first shot we did for this project. And it's also one of the most complex. So how everything began, really? It all began with just a simple ground. This ground was created with some displacements on ZBrush, and it was just imported. It's just a ground in the zero axis. With this, we then created a camera, which is this one. We added some footage where we exported a sequence starting from the frame 10:01, and then it was animated. And as you can see, it kind of follows the perspective of the video. If we were to just do a simple and generic grid, you will see that if we go into this view, that the grid kind of resembles the perspective. This is good enough for our needs, and we can start moving from there. So the next step was to actually create the houses. So these are all the same. This is just a house kind of center into where we need, and it was transformed. We transformed it so we can kind of copy this situation, but it was different. As you can see, it's like a slope. So what we were doing? Firstly, we separated everything that's as you can see. If we were to see the polygons, everything is a single polygon. So we had to subdivide this quite a bit so we can have more resolution when bending it, because we are going to be bending this. How? Well, we just grab a box where we need this to be edited, and this box is then moved like so and subdivided. This is also subdivided, and our lattice is going to do all the heavy lifting for us. As you can see, this is already moved. We can just mess around with this. It is quite a bit of geometry, but it just works. This is what we had to do. To fake the perspective, everything is fake. Nothing is actually real. But if it works for the shot, let it be. Look at this. This is so strange. It wouldn't actually work in real life scenario. Plus, everything is the same, but from the camera, you can't really tell that everything is the same. Then it was moved a little bit to where we need. It was merged with the other house, which is at the back, and we got our houses, which are then saved with a Prism file cache. The difference between a Prism file cache and a normal cache is that it just saves into the pipeline. If I go to project browser and I go to products, I have all these caches saved here, and I can easily access them with a simple import Prism file. So this is called houses. So if I go and load version, I can go to houses. Where are the houses? Houses here, and I can just load this same cache. See, it's exactly the same, and it works between shots and scenes, which is really handy. Then all I did here is just to unpack it. I did a UV transform, which didn't. This is useless. I'm not going to be using this in the shading process. And then I split everything that's at the back, or in this case at the front, and everything that's at the back, because I'm going to be separating them in the render. And plus, it's always nice to have everything cached. Moving to the walls, these walls are very nice. The tool is quite complex, but I'm going to try to explain it as briefly as possible. It all began with a simple box and a lid. This is how we actually want the shape be. We then subdivide this so it's kind of look a little bit better, and we add a box. This box is to bool and everything. So with this, what I'm going to be doing is to place it here, and as you can see, I can start moving the shape of the wall, and it will just work in some places, in some others it won't. As you can see, it usually works. And how is this actually done? Well, with all this, firstly, we get the first shape and we add a connectivity node because we want to iterate, or because this works if you have multiple shapes. Then I'm going to go into this one and just poly reduce it. This is very interesting. You need to have this and you need to keep 6 polygons, mainly because I want all of them, of these points, to be the same. So if I blast these two guys, I then can raise the box up to where I need, up to the top part of the actual shape, which is this one. And then I can match size box chest to get just to align it perfectly. This has to be perfectly aligned to our original source in scale. If I then pick a little bit, this is it looks like nothing, but it's essential to avoid errors. I'm just picking this. You will see I'm picking the points 5 and the points 4, the point 5 and 4, which is this one. And then I'm also picking the 0 and the 1, which is the other side. I'm just adding a little bit on the primitives. The 0 and the 1 right here, 0 and 1, and 5. Where is the 5? 5 here, and the 4 here. So on the sides. Then I'm booleaning this. I'm removing what I do not really want, and I'm picking it a lot. This will be where I'm going to be deleting the boxes, and I'm then adding another boolean here. So this is everywhere where we do not want our boxes to be. Here I'm using a little bit of mathematics, but basically I'm calculating the length, the width, and the height based on the points. The point 3 and 2, it's where this is 2, this is 3, this is going to be the length, the height is going to be the 0 and the 2, so the 0 and the 2 in this case is not correct, and the width, which is going to be the 0 and the 5, which is this one. So I'm going to store these values. I'm going to set the names. If you want to see what's going on, all I'm doing is, hey, per piece, set the names. The name is going to be equals to wall plus this string plus the number of the primitive, which is in this case the 0. That's all I'm doing right there. And then I'm adding, oh, this is very interesting. I am getting these attributes right here, and I'm making a new box. This new box is going to be grabbing from this per parameter, which is done adding a per parameter input like this, and grabbing these values, and I'm centering them a little bit right here. This could actually be the same. I don't know why it's there, but it's the same because it's then going to be match size in the middle. Going back here, where I am targeting some points, this is the if target A Y is bigger than target A B, I'm going to displace this to the bottom, and if the other way around is the same. So let's say target A is the point 0, which is which is this one. If that one is bigger than the other one, so if one of these 2 points is different from the other, it doesn't matter which one, everything which are from these points are going to go to the maximum value. Basically, I'm just flattening the surface on the top. Well, here I'm also setting the names. I'm setting the names here, and I'm setting the names here, and I'm extracting the centroid. This is very important to extract the centroid. I'm matching the size here, and I'm copying it. But as you can see, this is not properly oriented. We will orient it later on. So I'm going to actually promote this and extract the transform. I'm extracting all these values here, the orient and the pivot. This is key This is real key for us to change, as you can see, the orientation. Is here when we calculate the difference, because we copied it here, but we also got our orientation. You can see it's this one. This is the displacement or the change in orientation we're getting right here, right? It's, as you can see, it's oriented. And then I'm doing a little bit of math right here, and this will be the base. This is our base geometry. There's a lot of things going on here, and I went to this one because this is a wall which is working without any bugs, or it's easily to comprehend. So basically, once I get this position, which is basically I'm storing the rest, and then the position is going to be equal to the position of the first one, which is this one. Remember, this is how it's supposed to be looking, and this is our rest position. I'm grabbing this value, this object, and I'm sending it, and I'm matching a line at the bottom. And so this is where we're going to be building our actual wall. And measuring the size of this perimeter, I'm also resample this to whatever we want. And I'm measuring also this. So there's a couple of things going on here. Basically, I'm grabbing, these are going to be the boxes. These are going to be equal to the length of the wall. As you can see, there are a bunch of values or variables right here. So if I change this, it's going to be automatically edited. The same goes for this one. The same goes for this one, for the brick deletion and the brick shittering, as you can see. So this is the box I am creating on one layer on top, and I'm switching between these two. Basically, this switch is controlled by this constant. If it's constant, everything is going to be the same size, but if not, everything can be different. As you can see, it doesn't need to be constant. So this is the only thing it's doing, and I'm matching the size here, so it's centered on where we need on the x-axis, and these are all the points, and I'm just with this removing the last point because I don't want to have the last point, and then I'm just copying here. Basically, one box is going to be copied next to the other based on the length of this divided by what we actually want. And we're getting this value, and as you can see, we are just doing some quick math to get the size of the length and the height. In this case, the length, it would be the same as having, let's say, this value, or this value, which is the perimeter, divided by the amount of points I'm going to have here. So if the box is 1 meter and we have 3 meters of line and 3 points, each block is going to be 1 meter in length. I'm going to then be copy and pasting this, match sizing this exactly where I need on the minimum axis, and I'm going to move forward to the vertical part of this wall, which is this line, and it's the same concept. I'm matching the size based on what we need. I'm measuring this, and I'm saying, hey, we want a constant height, or we want a non-constant height. I'm calculating the perimeter, and I'm doing exactly the same thing for the height. This is the height is dependent on this value. As you can see, 17 is going to be here, 17. We're going to be around these points. We're doing a quick math, basically removing the last point again, and saying, hey, basically we are going to detect everything that's par or impar, and how do I say it in English? But basically every other number is going to have an attribute. It's either going to be 0 or 1. I'm going to be pasting everything on top of each other, grabbing a connectivity because it's always nice to have a connectivity on each piece, and I'm removing some blocks based well, these are all the values. Basically, I'm grabbing a shitter, this is a seed, this is a delete seed. So if there is a ramp right here, if the random between the class and the shitter is less than this threshold, all the position in the set axis and these are going to be moving by a certain value, right? It's going to be from a random between class from -1 to 1, and it's going to be multiplied by the same ramp and the same shitter move. Basically, this is the seed of the shitter. This is the threshold. So not all the blocks are going to be shittering, and they can be moving more or less with this ramp, as you can see. That's what's going on there. And this is the same for the deletion. Hey, if your value plus the delete seed, the random, is less than this threshold, you are going to be deleted. So basically, the deletion is, this is the seed, and this is the threshold, and a ramp, which is useless here. Move on, I'm going to promote the name to points, and I'm going to transform this to where I need it. Basically, I'm just moving it to the center of this box, to the maximum, in order for it to be aligned. Once I have this, I can set the name to the wall 0. I'm going to get the transform, and this is going to be placed exactly where I needed it before, right here, I guess. It's exactly the same shape. Then I'm going to set the names of the bricks. This is the same node. I'm just setting it the same way. There's nothing different. And I'm just assembling each of these guys into its own packed primitive, as you can see. So I can select the blocks individually. To finalize, there's a couple of things going on. This is the in, and I'm detecting if there are intersections. If there are, I'm going to be creating some places for deletion. And well, I don't even know if I'm actually using this. Oh yes, I am, because here what I'm doing is grabbing the value. I'm not really using this, if I'm not mistaken. I'm grabbing these guys, which are to delete, into delete, and grouping. If there's something to delete, this is going to be deleted. So basically, if I grab box and I place it here and I move it, you will see this is basically deleting all that I need, because I'm grabbing this box, and grouping all the bricks. I'm also grouping based on this wool. If there is something to be grabbed from here, which in this case there's nothing, and I'm blasting everything that's in the group. And that's how this wool was made. Once we have this, we are just going to be working to where we need. We are doing a couple of bricks, walls, and I'm then on a subnetwork doing a quick two things. We are doing a couple of BDB operations. Firstly, we're converting this back to polygons, and I'm scattering a lot of points. These points will be moved to different places. In this case, we're just going to be doing the hard part of this wall, but then we're going to be doing the concrete, and the concrete is basically just a bunch of points moved differently, like a big noise. So with the BDB combined, I'm just intersecting these two guys together. As you can see, it's like getting deleted. And I'm doing the opposite thing here. I'm growing the difference from this to this. So with a little bit of noise on one of these guys, which is basically the only thing is grabbing is the sample of the surface, adding the position to a noise. You can see that's about it. It's just a simple noise. On one side, I am having the actual bricks, which are going to be converted, and they look fabulous. And on the other side, I'm going to have the concrete. So if I merge both of these guys, I'm also preparing this. This was prepared to Maya. This is actually not really necessary, but all I'm doing here, I'm not going to be really explaining this because this is not done, but I'm going to go quickly on top of it. I'm setting the names like a path. This is a path for Maya. I'm deleting everything. I'm recalculating the normals. I'm also recalculating the class. I'm setting the name again. These are the concrete walls. I'm also setting the path again if necessary. I'm promoting the name to vertex. Well, that's basically it. Everything here it's nothing. It's just promoting the vectors to vertex, as you can see here, because Maya uses vertex for all its attributes, but we are not really using that here because we are ended up using a Houdini for this. So moving on, I'm setting the names. I'm overriding the names to brick walls and concrete walls. I'm merging these two guys together. This is how they look, and I'm doing the same for other walls, which are these ones. This is the same concept but with different sizes. I'm separating this for the back and this for the front.